Hi guys, welcome to the channel. So I'm not gonna tell you what we're gonna learn about today until you guess it on your own, or you'll have to wait until the middle of the video for a change because I think I always say the topic in the beginning and most of you get bored. Like, oh my god, I hate this, and you just stop watching the video and miss a lot of knowledge. So today I won't tell you what we're gonna learn until we're halfway there. Okay, so you stay interested and try guessing. Okay, the thing that we're going to learn about today is our favorite shape, that is a right angle triangle. Isn't it your favorite shape? We all love triangles, don't we? So this is a right angle triangle. What I mean by that is this is a 90 degrees angle. And then let's begin by labeling the triangle. So whenever you hear terms like the hypotenuse, what your professor or your teacher or your friends mean is the line of the triangle or the side of the triangle that is opposite the 90 degrees angle. Okay, so this one here is the hypotenuse, and the other two sides, okay, which hold the angle, are called the arms. Okay, so a very famous mathematician came up with a calculation that says that arm 1 a square, okay, arm 1 squared plus arm 2 squared, that is b square, okay, is equal to the hypotenuse squared. Okay, he said we can use this concept to find an unknown side of a right angle triangle. For example, you have a triangle like this. Okay, you've been given one side as 3 and the other side as 4, but you don't know the hypotenuse. How will you find it? So you can use this formula right here, or this law that by now you all must be knowing. It's called the Pythagoras Theorem. So you can use it to find the unknown side of a right angle triangle. Okay, and it's really important to remember it, to memorize it, because you'll need it for the rest of your life, not just in math but also in real world. Okay, it has a lot of applications in further mathematics and your life too. So cram it, memorize it, do whatever it takes, but do not forget that. So let's try applying it in this triangle to find the hypotenuse. Okay, by the way, hypotenuse is the biggest side of a triangle. Okay, so we know that whatever number this will be, it will be bigger than 4, because it's going to be bigger than 3 and 4. That basically means it's going to be bigger than 4. Okay, so let's find x. So the only thing that you need to do is whenever you get a question like that, excuse me, all you need to do is you substitute. Okay, so this is your a, 3 square, this is your b, 4 square, and this is your c, x square. Okay, so 3 square, if you haven't watched my squares and square root videos, please do go watch it, because it's going to help you with Pythagoras theorem. That's like a basic concept in this topic. And if you have, let's go on with the video. The 3 square means 3 times 3, that is 9. Okay, 4 square means 4 times 4, that is 16, is equal to x square. Okay, so 9 plus 16 is 25, is equal to x squared. But we don't want x squared, we want x alone, right? Because this is just x, not x squared. So how will we find that? Simple, really simple. All you need to do is you put both of the sides under the square root sign. Okay, so the square root of x squared is x, and the square root of 25, if you guys remember, is 5. So now you know this is 5. Okay, now since we've solved for x that we got as 5, let's use this triangle to understand the concept behind Pythagoras theorem. So we have a triangle right here with the dimensions 3, 4 and 5. Okay, imagine having a square on each side of the triangle. That means having a square here. Okay, having a square here and having a square here. Oh, that looks more like a rectangle, but it's actually supposed to be a square, right? I'm not a good artist. Not all mathematicians are, so don't worry even if you're not. As long as what you're explaining or what you want to show your professor is visible, that's fine then, okay? Now, one property of squares is that both sides are equal. So that means this side is equal to this side, right? And the area of the square will be found by doing a equals to side square, that is 3 square, okay? The same goes to this one. A will be equal to 4 square, and here a will be equal to 5 squared. Fine. Now let's visualize the square, okay? So we know that the side is 3. The dimension is 3 units, whatever it is. So let's divide it into 3. 1, 2, 3. The same for this side. 1, 2, 3. Now we have 3 sides, 3 sides. So 3 times 3. How many squares do we get? 3 times 3 is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So the area is 9. Remember this, okay, for the further explanation. We do the same thing here because it's 4. Okay, the dimension is 4. You divide the square into 4 units. And because also this will be 4, you divide it into 4. Let's count the squares. So 4 times 4 is 16, but let's just make sure for your own benefit. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay. We do the same thing here. Because it's 5 units, you divide the square into 5 units. And we do the same thing for this side. So that's going to be like 1, 2, 3, 4, and 5. Okay. That doesn't look like a square, but that would do. So if you want, the area will be 25 square units. Let's just check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Okay. Now if you guys have noticed something, 9 plus 16 is equal to 25. 9 plus 16 is equal to 25. But where did we get the 9 from? We got the 9 from 3 square. Where did we get the 16 from? We got the 16 from 4 square. Okay. Where did we get the 25 from? We got it from 5 square. Okay. And what is 3? Let's compare this triangle to this one right here. 3 is A. 4 is B. And C is 5. 5 is C. So let's resubstitute it, and now you get the Pythagoras theorem. Okay. So that's how the law came up. Okay. You used the concept of areas. If you guys have understood it, please give the video a thumbs up and continue watching for more examples. Okay, because we are going to be solving for unknown sides of some more triangles. That one of them being this one right here, where you're given the hypotenuse as 10 and one arm as 6, but you're not given for the base. So how will you find the base? To do that, let's use the Pythagoras theorem again. A square plus b square is equal to c square. But guys, if you guys have noticed something, we're not looking for c this time. We are looking for b. We're looking for the base and not for the hypotenuse. We're looking for one arm and not for the hypotenuse. But then this formula here is for the hypotenuse. Don't get nervous, don't get scared. It's just a little rearrangement. That is basic algebra. If you don't know algebra, please do go watch the video on my channel for a better understanding of the concept. So you you want b squared to be alone, so you take a squared to the other side. Because it was plus, it will become minus. So that's how you can find x. Now let's just substitute. B is x, c is 10, and a is 6. Okay, Let's simplify. 10 times 10 is 100. 6 times 6 is 36. So x squared is equal to 64. 100 minus 36 is 64. I know I'm a little quick, but after some practice, even you will be really fast. So don't worry. Stay patient, keep practicing, and let's continue. So to get x alone, because we don't want x square, we want x alone, you need to put both under root. Okay, so under root x square and under root 64. So under square root of x square is equal to x, and square root of 64 is 8. So 8 units. Just a precaution, guys, make sure that all the units, okay, all the sides of each unit is the same, because if one will be in meters and the other one will be in centimeters, the answer you'll get will be different and wrong. So make sure the units are the same when you before applying the Pythagoras theorem, and be sure you're substituting the right term with the right side. Okay, don't substitute a and b with the hypotenuse, that would be wrong. You can use any arms for a and b, but c should always be the hypotenuse. Don't get confused. And sometimes in other sides you'll find the Pythagoras theorem is x square plus y square is equal to z square. Don't get confused, it's still the same thing. It's just that you can just easily compare and know that a is x, b is y, and c is z. So z will be the hypotenuse, but do not get confused. It's the same thing. Okay, don't get nervous. For your own practice, I'll be writing another question here, so practice, and if you get the answer, write it in the comment section below. If you need more help, email me at funlearn@gmail.com. And here you go. 20 and 14. If you enjoyed the video, please give the video a thumbs up and be sure to subscribe for more content. Have a good day.